Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad algebra problem, and here we have a times of a into b equals to c square. So here this a, b and c are integers, and this a and b denoted by the four-digit number, and it is equals to the perfect square of a single number c. So here we have a and bb makes the four-digit number, and it is equals to the perfect square of a number. So we find the value of this perfect square c, or we find all the values of a, b and c. So that here first we little bit explain this expression, and here first we rewrite it as a into a b b. So here you know that this number will be lies in the ones place, so we call this as ones digit. Okay, you know that if it is ones digit, so we multiply b by the 1, and similarly this b lies in the tens digit place or tens place, so that we multiply this b by 10 because it is lies in tens place. And similarly this a is lies in the hundred place, so we write this a is lies in hundred place, so we multiply this a by 100. And similarly this a is lies in thousands place, this is lies in thousand place, so that we multiply this a by 1000. And now we combine all these expressions, and we write this number a and bb equal to, so we write AABB equals to, because this A lies in thousand place, we write it as 1000 times of A, and this A lies in hundred place, we write it as 100 times of A. This B lies in tens place, we write it as 10 time of B, and this lies in ones place, and we write it as 1 time of b. And here when we add 1000 plus 100, it will becomes 1100 into a, and when we combine these two, then we get here 11 times of b. So here we take common 11, and you get here 100 a plus b equal sorry, this one. So now you see that because here we find the product, we find this number equals to some perfect square, so here we make a perfect square. So in order to make the perfect square, so we here you have this number will be the multiple of 11, so each number would be the multiple of 11. So now we can write we can convert all these numbers into the multiple of 11. So we write this 100 as 99a, because 99 is multiple of 11, and plus a, we write this 100 as 99a plus a, and here we have plus b. So here you know that a and b are any integers, so here we, in order to find the multiple of 11, so it means that this a plus b must be the a number which is multiple of 11. So here we call this as equation number 1. And now we can find a plus b. So we know that this a plus b is a multiple of 11, and multiple of 11 are 11, 22, 33 and 44 and up to so on. So these are all numbers which are multiple of 11, and now we can check that a plus b is which of these number. So that here we it means that our a and b are the value of first 9 integers. It means that our a and b must be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So our a and b are any numbers between 1 to 9, or we can sum up all these numbers, so that you get here the sum of two numbers will be equals to multiple of 11. So we find any two numbers here in which the sum of these two numbers becomes the multiple of 11. So here if you add 1 and 2, you get 3. If you add 2 plus 3, you get 5. And 3 is not multiple of 11, 5 is not multiple of 11. If you add 3 plus 4 is 7, and it is not multiple of 11. If you add 4 plus 5 is 9, is not multiple of 11. And 5 plus 6 is 11, and it is multiple of 11. And we have 6 plus 7 is 13, it is not multiple of 11. A 7 plus 8 is 15, it is also not multiple of 11. 9 plus 8 is 17, it is also not multiple of 11. It means that if you add any two numbers from these numbers, then you get the maximum value is 17. So you cannot get the value greater than 17. You add any two numbers. So it means that if you our greatest value is 17, so it means that we cannot get all these values, but here we just get only one multiple of 11, and which is the 11. So it means that our a plus b equals to 11. So now we can choose from these a plus b equals to 11, and we call this as equation number 2. So here we put the value of a plus b equals to 11 in this equation number 1. So here we write from equation number 1, the equation number 1 is a b b equals to 11 times of 99a plus a plus b. So this is our equation number 1. So we put the value of a plus b is here. So a plus b equals to 11, so that we will get a into bb equals to 11 times of 99a plus 11. Because here we our given question is bb equals to c square, so it means that we convert this number into the perfect square, so we can make all these things. So here you take common 11, and you get here 11 square into we obtain 9a plus 1. So that here we get the value of 9a plus 1. And in order to find the value of 9a plus 1, you will see here we choose our, so here our target is to find the value of 9a plus 1, and we call this as equation number 3. And in order to find the value of 9a plus 1, and we know that our a equals to any value of the first 9 integers, so it is first 9 natural number, it is 1 2 3 4 5 6 7 8 9. So our a must be the value from these 8 or 9 integers, 9 numbers. So we put the value, we choose any value from here which gives us the multiple of 11. So you remember one thing is that we can find the multiple of 11. So our 9a plus 1 must be the multiple of 11. So here we find the value of a from here, which satisfies the and which gives the multiple of 11. So now we check one by one all these values. So here if you put a equals to 1, then you get 9 into 1 plus 1 equals to 10, and 10 is not multiple of 11. And if you put a equals to 2, then you get 9 into 2 plus 1 equals to 9 2s are 18, 18 plus 1 is 19, and it is also not multiple of 11. If you put a equals to 3, then you get 9 into 3 plus 1, and 9 3 is 27 plus 1 is 28. It is also not multiple of 11. And similarly you put check at a equals to 4, and you get 9 times of 4 plus 1 equals to 9 4s are 36 plus 1 37 is not multiple of 11. And a equals to 5, you get 9 of 5 plus 1 equals to 9 5s are 45 plus 1 is 46 is not multiple of 11. And if we put a equals to 6, then you get 43. Here you get 9 6 are 44, and 44 plus 1 becomes sorry 9 4s are 54, and 54 plus 1 becomes 55. It is not multiple of 11. So here we find the number which is perfect square, because here we already find the multiple of 11, and it is the perfect square. 11 is the perfect square, so we find this number must be the perfect square. If this number is also perfect square, then you get here the perfect square. Here we find the perfect square. All these numbers are not perfect square, and when we put here a equals to 7, then you get 9 of 7 plus 1. 9 7s are 63, and 63 plus 1 is 64. So 64 is the perfect square, because we write it as a square, 8 square. So here we have the value of a becomes 7. And now we put the value of a equals to 7 in equation number 2. So this is our equation number 2, and here we put the value of a equals to 7, and we get the value of b. So when we put a plus b equals to 11, we put the value of a equals to 7 here, then you get our b equals to 11 minus 7, and b equals to 4. So we have a equals to 7 and b equals to 4. And we have the value of 9a plus 1 is 9a plus 1 equals to 64, and 64 equals to 8 square. So we put the value of 9a plus 1 equals to 8 square in equation number 3. So this is the our equation number 3, and we can put the value of 9a plus 1 here. Then you get the value of b equals to 11 square into the value of 9a plus 1 is 8 square. And now we will combine the value of 11 square and 8 square. It will becomes 88 whole square, so that we have the value of a and b is 7 and 4, so that we have 7 7 4 4 equals to 88 square. So we have this 4-digit number equals to perfect square of 88. So we have the value of c equals to 88, and this is the our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.